Today's lesson is 6.3 binomial radical expressions. We will be adding these radical expressions, subtracting, multiplying, and dividing. So first we'll start out with adding and subtracting radical expressions, and we can only add and subtract our like radicals. So what a like radical would mean is it would have the same index and radicand. Okay, so for example, if I have the cube root of 4x, okay, a like radical would have to be a cube root of 4x and then any coefficient in front. Those would be two like radicals. Okay, so very similar to like terms. Okay, so for our first couple problems, we're going to simplify here. So for number 1, I'm taking 4 square roots of 6x minus 2 square roots of 6x. So they are both a square root. So that would mean they have the same index. They both have 6x inside of the radical. So that means they have the same radicand. So I can subtract these. And when I subtract them, I am subtracting the coefficients in front. So I'm taking 4 minus 2. So that would be 2 square roots of 6x remaining. Okay, if it makes sense to you that when I say 4 square roots of 6x, so I'd have 1, 2, 3, and 4. That would be the long way to write 4 square roots of 6x, and then I'm taking 2 of them away. So then what am I left with? When I take away 2 of those, I'm left with 2. Okay, if that idea makes sense to you, or if you think of it, if I was asking you like 4x minus 2x would be 2x, you're not subtracting off your variable. You're not subtracting off the square root of 6x. You are just subtracting the numbers in front because that's telling you how many of those square roots you have. Okay, and that's all there is to it. No work really for anything like that. Okay, for number 2, I have negative 3 square roots of 5 minus 8 cube roots of 5. They both have the same radicand, but they do not have the same index. That one's a cube root. There's no number here, so this is a square root. So I cannot simplify it any further. There's nothing more I can do. So I'm going to say cannot simplify. I forget, I think there's just like a multiple choice that you push in Math Excel that says like already simplified or something like that, or you type in your simplified answer. Okay, so there may be some that you cannot simplify because they don't have the same index or radicand or both. Okay, so those shouldn't take you very long to do. Also with adding and subtracting, when I look at my next example for number 3 here, you would look at these and go, well, they are all cube roots, so they all have the same index, but they do not have the same radicand. This one's different. This one I can simplify to see if I could possibly add and subtract, because I can simplify the cube root of 250 using some of my perfect cubes we've been talking about. So 125 is 5 cubed. That's a perfect cube. If I multiply 125 times 2, I will get 250. So the cube root of 125 is 5. And then you have 5 cube roots of 2. So I simplified my 250. Okay, next I'm going to simplify, put it over here. The cube root of 54 would break into 27 times 2. The cube root of 27 is 3. We are adding, so plus 3 cube roots of 2. Okay, my last one I'm going to put over here. I'm subtracting, so don't forget that. I'm going to break up the cube root of 16 into the perfect cube 8 times the cube root of 2. 2 times 8 gives me 16. What is the cube root of 2? Sorry, what is the cube root of 8? That would be 2 cube roots of 2. Okay, so now when you look at these, they are all like radicals at this point because everything's a cube root of 2. So then I'm looking at taking 5 plus 3 would give me 8, minus 2 would give me 6 cube roots of 2 in my answer. Okay, so on one like number 1, there was nothing to simplify inside, and they already had the same radical, so we could just go ahead and subtract those. One like number 2, we couldn't simplify anymore, and they also did not have the same index. So if they don't have the same index, there's nothing you can do to simplify it any further. If they do have the same index, you will need to double check if they are all simplified. If they were already simplified, then it would be done from when we started, but I will need to first check to simplify to see if I can combine anything else together because they may be like radicals. Okay, so that's it for adding and subtracting. Next, we'll look at multiplying binomial radical expressions. So radical expression is going to mean that you have a radical somewhere in there. Binomial means there are 2 terms. So I have 4 plus 2 squared to 2. That is a binomial radical, and then I'm multiplying it by 5 plus 4 squared root of 2. Okay, it'll be very similar to how we've multiplied binomials before. You can use your FOIL method to do this, or you can just think of it as I'm distributing 4 times each of those things. Okay, I'm going to write this out kind of a long way right now. So 4 times 5 is what I'm multiplying first. You can absolutely write down 20 if you want. But then next I have plus 4 times 4 square root of 2. So I want to come back to that and make sure we're multiplying the proper things together. Next I got my inside term. So I have plus 2 square root of 2 times 5 and plus 2 square root of 2 times 4 square roots of 2. Okay, so I'm writing this out in a longer form just to kind of do this the first time. If you're able to skip to this next step that I'm going to do, that's totally fine. Many of you would put 20 before you write down 4 times 5, but I wanted you to look at the ones that have radical parts to them, because when I'm multiplying 4 times 4 square roots of 2, I can only multiply together the numbers that are outside of the radical. So only 4 and 4 are being multiplied, so that would be 16 square roots of 2. Okay, plus 2 square roots of 2 times 5. This 2 is in the radical. That cannot be multiplied by the 5, but the 5 can multiply that 2. Okay, I can rewrite this as 5 times 2 square roots of 2. It means the same thing as 2 square roots of 2 times 5. So if it helps you to reorder them, you can, but that would give me 10 square roots of 2. Plus, this last one here, the 2 and the 4 are both on the outside. That would multiply to get 8. And the 2 and the 2 inside the radical can multiply each other. Right? If I'm taking the square root of 2 times the square root of 2, I get the square root of 4. Okay, it doesn't matter that there's a 2 in front of the square root of 2 and a 4 on the other square root of 2. I'm just multiplying everything. I am not combining any like terms at this time. So that would give me the square root of 4. Okay, from here I'm going to continue to simplify. So I've got my 20. Now I have 2 like radicals that can be combined. So 16 square roots of 2 plus 10 square roots of 2 would give me 26 square roots of 2. Plus the square root of 4 is 2. So I'm truly multiplying 8 by the value of 2. Which means 20 plus 26 square roots of 2 plus 16. So I can combine 20 and 16. So I'll get 36 plus 26 square roots of 2. And then here's where I'll see a few students get very tempted to add the 36 and the 26 together. I cannot do that because this 36 does not have a square root of 2 attached to it. So they are not like radicals. The 36 has no radical at all. So I cannot add it to another number with a radical. Okay, so this would be my final simplified answer. All right, we are going to move on to division. So we use this term conjugates when we were multiplying complex numbers when they had, something like 4 plus I. Okay, we talked about a plus bi and a minus bi. If you remember doing anything with that, we had complex conjugates. Now we have these radical conjugates where you notice they have the same exact numbers, but the signs in between are opposite. Okay, so they differ only by the signs of the second terms. The product of the conjugate is a rational number, so we're going to get rid of that square root. Okay, so when we rationalize this denominator, I'm going to have to use the conjugate. Okay, if it would have had something like 4 square root of 2 over 3 square root of 2, I do not need to use a conjugate. A conjugate's only necessary when I have 2 terms. Okay, if I have 1 term, I can just go ahead and multiply it by the square root of 2 to get rid of that radical in the bottom, like we've been doing with rationalizing the radicals we've had so far, because they were not binomial. Okay, they did not have 2 terms separated by addition or subtraction. Okay, up here, if I would multiply that by the square root of 2, which I will see some students try to do, you are distributing that. So I'm going to take that 2 times that square root of 2, which would mean that I would create another square root in my denominator, which I'm trying to get rid of. So it will not work. The only thing that will work is to use the conjugate. Okay, so that would be 2 plus 3 square roots of 2. I didn't change anything but the sign in between them. And then what I multiply the bottom by, I must multiply the top by. And then I just do a bunch of distributing. Okay. So I've got 4 times 2 is 8. 4 times 3 square roots of 2, remember I'm just multiplying the numbers outside of the radical, so that would give me 12 square roots of 2. If I take 2 times the square root of 2, that is 2 square roots of 2. And then I am multiplying the 3 square roots of 2 times the square root of 2. Remember, the numbers inside the radicals would multiply to get 4. Okay, then I'll multiply out my denominator. 2 times 2 is 4. 2 times 3 square roots of 2 would be 6 square roots of 2. Then we have minus 6 square roots of 2. And then minus 9. Make sure you take the 3 times 3. And the square root of 2 times the square root of 2 would be the square root of 4. Okay, we've got some simplifying to do. So I've got 8. 12 square roots of 2 plus 2 square roots of 2 would be 14 square roots of 2. 3 times the square root of 4 is 2. So that would be 3 times 2 would give me 6. In my denominator, I've got the 4. 6 square roots of 2 minus 6 square roots of 2 would cancel out. The square root of 4 would be 2. So I'm taking 9 times 2. So I have 4 minus 18. Okay, so if I look back up on top, 8 plus 6 would be 14, plus 14 square roots of 2, divided by 4 minus 18 would be negative 14. And then just like we did in the past, if you can continue to simplify, you should, because I can rewrite this as 2 separate fractions, because both of those numbers up, or both of those terms up on top are being divided by negative 14. So this would give me negative 1. 14 and 14 would also give me a negative 1 square root of 2. So that will be my final answer. Sometimes it'll be in a fraction form here. Like if I would have had a 13 in the bottom, then I would have put 14 plus 14 square roots of 2 over 13. Okay, totally fine, but that wasn't what we had. Okay, so that'll be division. We use the conjugate when you have 2 terms in your denominator and you need to rationalize. Okay. All right, so then I put 4 problems here, one of each type. more than one of each type. Some are subtracting, adding, multiplying, and then using the conjugate. Just do a quick check to see if you are understanding that concept. I did not do many examples of those. So my suggestion would be to pause the video, try those 4 problems. You got the solution bank to check your work, and then come back and rewatch the video and make sure you got them correct. Okay? All right, with this first one with number 1, they have the same cube root, so the same index. -9 is the same in both of the radicals, so that means they are like radicals. There is my invisible 1 in front of there, so I'm adding the coefficients. 1 plus 8 would be 9 cube roots of -9, which you should see in your solution bank. Number 2, I must first simplify those radicals to see if I will be able to combine any like radicals together. 54 would break into the cube root of 27 times 2, cube root of 2. Cube root of 27 is 3, so I've got 3 cube roots of 2. 250, I've got the cube root of 125 times the cube root of 2. That's a minus in between. Cube root of 125 is 5. Cube roots of 2. Over here, make sure you keep that -2 out in front there. That's an easy one to forget. And -128. Now you want to pull the negative out. So I'm going to use -64 times the cube root of 2. I don't want to put my negative with that 2, because if you already look at our pattern here, we want to have a cube root of +2, so that we'll be able to combine these together. So I need to have the negative in the cube root that's going to come out. So the cube root of -64 would be a -4 times the cube root of 2. Okay. So I have 3 cube roots of 2 minus 5 cube roots of 2 would be -2 cube roots of 2. And then this -2 times -4 would turn it into a +8 cube roots of 2. So then I'm combining -2 plus 8 would be 6 cube roots of 2, which you would see in your answer bank. Okay. Number 3, I'm distributing this. So I'm taking 3 times 5 would give me 15, plus 3 square roots of 7, minus 5 square roots of 7, minus the square root of 49. Make sure you multiply the 7 and the 7. Now combine any like terms or like radicals you've got. So 15, 3 minus 5 would be -2 square roots of 7. I can take the square root of 49 and get 7. So then I will take 15 minus 7 to give me 8, minus 2 square roots of 7. I cannot subtract 2 from that 8. It does not have a square root of 7 attached. And then the last problem, check for your understanding here. I am going to multiply by the conjugate because I have 2 terms. I have the square root of 5 and the square root of 2. So I'm going to multiply by the square root of 5 plus the square root of 2 on the top and bottom. So when I distribute across the top, that 3 is staying on the outside, but the 2 and the 5 inside would multiply to the square root of 10. Then same thing, the 3 would stay on the outside, and the 2 would multiply inside to be the square root of 4. Okay. Then in my denominator here, I would get the square root of 25. Distribute across, plus the square root of 10, minus the square root of 10, and then minus the square root of 4. So simplifying from here, the square root of 4 is 2. So I have 3 square roots of 10 plus 6 over the square root of 25, coming from here, is 5. Those would cross out, minus 2. So 3 square roots of 10 plus 6 divided by 3. Then once again, check to see if you can divide both the top and bottom by 3. Yes, we can. So I'd be left with the square root of 10 plus 2, because I divided this 3 and this 6 by 3. Okay, that is our lesson today. Good luck in your homework.